Hello students, in this video we are going to discuss a problem of stationary waves. Here the vibrations of a string fixed at both ends are represented by this equation, and we have to find the phase difference between 2 points which are located at 13 and 16 centimeters. So let us look at the question. Here I am also showing the standing wave formation in the animated GIF image. So the equation of the standing wave is given like this. The vibrations of a string fixed at both ends are represented by this equation y is equal to 16 pi x. So see, this equation can be compared with the standard form of the standing wave equation. Y is equal to a sine kx into cos omega t. So you can, by matching both the equations, we can say the value of k, which is called propagation constant, k is equal to pi by 15. Okay, and by definition you know that k is equal to 2 pi by lambda. This is the definition. 2 pi by lambda is k. K is called propagation constant. So by making them equal, both of these making equal, we can find out the value of the wavelength. So let's write down that pi by 15 is equal to 2 pi by lambda. Pi cancel from both sides, and we get lambda is equal to 30 centimeters. Now, after getting this lambda is equal to 30 centimeters, we can find out the phase difference between the two by using this formula of the standard phase difference, that phase difference delta phi between 2 points is equal to 2 pi by lambda multiplied by delta x. Now the value 2 pi by lambda is already is equal to k, that is pi by 15. So directly we can write down that 2 pi by lambda means pi by 15, and delta x means the distance between the 2 points. Delta x is x2 minus x1. That means pi by 15 multiplied by, so the 2 points are located at 13 centimeter and 16 centimeter. So 16 minus 13, which is equal to pi by 15 into 3, therefore pi by 5. So this seems to be the answer as pi by 5, but however the answer key given in the book is this one. So now let us see what explanation has been given by the book writers regarding this question, why the answer is pi. So I am drawing the standing wave here. As you can see above in the diagram, there is this black color thing is the standing wave. So at particular instant of time, let us say the standing wave looks like this. And these points here, these red color dots shown above, these are nodes. These are nodes. We also know that the distance between the adjacent nodes is lambda by 2. Okay. So see here, value of lambda 30 centimeter. So therefore node to node distance lambda by 2 should be equal to 15 centimeter. So this is 15 centimeter. Now obviously the first node should be at x equal to 0. X is equal to 0. Because if we put x equal to 0, then you get y is equal to 0. So of course at the first point here x equal to 0 and y also equal to 0. So x equal to 0 the first node, then the next node should be at x equal to 15. So this particular node is located at x is equal to 15 centimeters, and definitely this one is x is equal to 30 centimeters. Now look at these 2 points given the question. One point is at 13 centimeter, other is at given at 16 centimeter. So at 13 centimeter means here. So this particular particle has now gone up here. This particle is located here now, above, some height above this point. So this is x equal to 13 centimeter, and that particle has gone up at this moment. And x equal to 16 would be on the right side of 15 centimeter, that means here. So this particular particle has gone down. So look at the particle P and Q. Okay. So basically they are asking that what is the phase difference between the particle P and Q. Okay, these are the two particles located at x equal to 13 and x equal to 16. So the explanation for answer is that because both of these are located in the opposite loops. Okay, that means with respect to the node, P is on the left side, Q on the right side, and P is gone up, Q has gone down. Therefore, the phase difference is taken as pi. The answer is equal to pi. But truly speaking, I don't believe in this solution. According to my view, the phase difference must be pi by 5, because if we again analyze these particles P and Q, if the logic is only that simply because these two particles belong to the adjacent loops and they're in the opposite direction, so therefore their phase difference is pi. That means if you take any random particle, for example, let me say one particle A I'm taking on the left loop and another particle B I take on the right loop, then even between these two also the phase difference should be pi. Or if I take a particle here, let's say C, and other one I take D on this side, anywhere, let's say here D. So between C and D also answer is pi. So that means between A and D also phase difference pi. Between C and B also phase difference pi. That means irrespective of the x coordinate of all the particles located in the first loop and all the particles located in second loop, between any two random particles between them, the phase difference is pi. So that doesn't seem to be correct. But anyway, this is the answer key given the question. What is your belief, students? Kindly write down in the comments and tell me that what is your view about the solution of this question. And here is also I'm putting the screenshot of this solution as written on the website of this book publishers. So here also the explanation is given the same in order to support their answer as pi radian, that k is equal to 2 pi by lambda, so therefore lambda is 30 centimeter. And then the reasoning is that because they vibrate in the opposite phase, that they are located in adjacent loops. Because these particles are located in the adjacent loops here and here, and therefore they vibrate in the opposite phase. Therefore, their phase difference should be pi radian. So kindly write in the comments and tell me that what do you believe about the answer. Thank you for watching the video.